Okay, ladies and gentlemen, let's review how you factor. The very first step of factoring is always factor the GCF, the greatest common factor. That's the first thing that we need to do, always. Then we get down to different kinds of factoring. After you take out the greatest common factor, you may be left with 2 terms. You might be left with 3 terms. You might be left with 4 terms. So we factor these differently. This is a total review. We've already talked about this. If you have factoring 2 terms, you're factoring 2 terms. As of today, before I teach you something new, all we know how to do is factor what's called difference of squares. And those are the kind that look like a squared minus b squared. And we would factor a squared minus b squared to be a plus b times a minus b. So if it has 2 terms, you're looking to see if you can factor that. But today, I am, later in the class, going to add on something else that goes for 2 terms. Could also be a sum or a difference of cubes. And there is a formula for that, which I guess I could sneak it in here. If you don't have room, it's on the next page, but I'll put it right here because I have room. Formula. Okay, so we will be learning that part in red later today. If we are factoring 3 terms, a trinomial. Does anybody remember how we factor a trinomial? Guess and check. That's where you just make, I don't know what happened there. You just make the 2 parentheses. Hold on a second, something's going on here. What's going on with this computer? You make the 2 parentheses, and then you sometimes like x and x, and you figure it out. What's the check part? You foil it back together. I don't know why that will disappear. There. Okay, got it. All right. Does anybody remember anything about factoring 4 terms? Into groups? Yeah, we're going to factor by grouping. Factor by grouping. And then after you factor these, anytime you get a binomial, for example, guess and check, we get 2 binomials. Anytime you get a binomial, you do need to check to see if the binomial factors factor further, which you will have today. More factors. Okay? Just always check. So this is a review with the exception of sum or difference of cubes, which we'll learn about halfway through our lesson. So the first thing I'm going to do is I'm going to go kind of fast because it's all review. Let's factor these. All review. What's the first step? Is there a greatest common factor for number 1? What is it? Factor out by x. It goes outside of the parentheses. We have x squared minus 7x plus 10. Why does it say student practice? I went too far, didn't I? Whoops. That's all right. Same thing. Factor out your x. I've already half done your next question. We get x squared minus 4x minus 5. Then after you take out your x, you have a trinomial left over. How do we factor a trinomial? 3 terms. Guess and check. So we're going to bring down our greatest common factor, and then we're going to have 2 parentheses. When we look at the first term, it's x squared. X times x makes x squared. Look at our last term, it's minus 5. I could either do minus 5 times plus 1, or I could do minus 1 times plus 5. Which one has to be negative? The 5. So minus 5 plus 1. And then we look at our binomial. The term, the factor x minus 5. Can that factor factor further? It's two terms. How do we factor two terms? Difference of squares. Do we have perfect squares here? No. And then difference of cubes, you haven't learned that yet, so I'm not going to give it to you yet, but also this is not a cube. It doesn't have a third on it. How about x plus 1? That's difference of squares. Well, difference means subtraction is not subtraction, so this one does not fit into this category. So anytime you have a power of 1, it's not going to factor further. So I could have just stopped here and not even think about that. We need to check to make sure it's factored all the way. All right, next question. What's our first step? Is there a GCF? Yes. What is it? 3 y to the third. So we have 3y to the third multiplied by y to the second minus 16. And we look at our binomial. After we take out 3y to the third, we say that's two terms. What are my options for two terms? Difference of squares? What's difference mean? Is it subtracting two perfect squares? So then we will use the factoring for difference of squares. This is going to be y plus 4, y minus 4. Then I need to look at y plus 4 and see if that can go further. If y is to the first power, it won't be able to go further. So I know I'm done with that one. How about y minus 4? That one won't go further because y is to the first power. Well, that's factored. Third one, C. What do I do first? Is there a GCF? What is it? 5z squared. So we factor that out and we get z squared plus 6z plus 9. And then we have a trinomial. And we say, let's get some check. Z, everything's positive, so plus and plus, what makes 9, but also adds up to give me 6. 3 and 3. Ooh, those are exactly the same. So I have to write that as 5z squared multiplied by z plus 3 squared. So you've seen her practice 1, 2, and 3. You got 2 minutes to answer 1, 2, and 3. I've already started one for you. First step, always greatest common factor. Then factor what's left over. 1, 2, and 3. $75 cents. Ready to go into it? 75 cents. I mean, like, this is silly because maybe you all use credit cards. I don't know. Oh, okay. I was just trying to give you a way of dividing that without pulling the calculator out. Okay. If it's whole like 25, I do like money. Or if it's got 15, I think of time. you can finish. I put all the answers on the board. Don't look till you're done. The answer to be my last line. If you got it, you're good. Turn the page, go to example 4. That's the next one we're going to do. It's actually 2 pages. Not turning 2 pages, but it's on the second page. That's where we're going next. We'll be example 4. If you got a question, I'm walking around. Well, I'm going to do it just to review at least the first one I do. I mean, you're more than welcome to do whatever start working on it. You will not take a math class from now on where you don't factor. Factoring is part of everyday mathematics classes from now on. Not necessarily every day in your life, but when you're in math class, you have to know how to factor. So if you don't know how to factor very well as of today, we got to practice. We got to come in and get extra help. Watch some videos on YouTube. Maybe somebody can explain it better than me. I mean, I'm pretty good, but maybe there's something better out there. You guys have that resource. You didn't have YouTube when I was in school. Talk about what a sad life it was, huh? So I skipped ahead to example 4. I'm going to go back. Example 3. I skipped ahead to example 3. I'm going to go back to example 2 after this. All right. Does everybody see where we are? Example 3, top of the third, or top of the front of the second page. That's the example. We have done factor by grouping. It's been a while. Let's review. So the first thing you have to do is just group them however you see that you could factor it. All the ones we've done so far have been 2 and 2. It's not always 2 and 2. All the ones we've done so far have been 2 and 2, so we're still doing that. 2, and then you have to have a plus sign in between 2. Notice my subtraction stayed with the 4, the negative 4. The 4 is negative, the negative stays with the 4. So once we group them, then we look at each group separately. We factor each group separately. So we look at z cubed plus 5z squared. What's the first step of factoring? Is our GCF for that? Z squared. I'm going to factor that out. And I have left over z plus 5. Not a parenthesis. I'm going to factor it. First step of factoring is GCF. Is there a GCF in the second parenthesis? It is a negative 4. So we have a negative 4 outside of z plus 5. Now we look at the whole expression, and we say, can we factor this whole expression? First step of factoring, is there a GCF? So for each term around that minus sign, it will have a z plus 5. So you have to undistribute that z plus 5. It has to undistribute z plus 5. And then after I take out that z plus 5, what's left over? Z squared minus 4. We have done this before. And then I say, am I done factoring? So z plus 5, z is to the first power. I know that's done. Then I go to z squared minus 4. That is not first power. It might factor further. So we look on our first page. How do you factor 2 terms? On our first page, how do you factor 2 terms? Difference of squares or sum and difference of cubes. Have I taught you cubes? Okay, so it's not that yet. Might be soon, but it's not yet. So is this a difference of squares? Are we subtracting 2 perfect squares? Is it subtraction? Is it perfect squares? Will they square root? Yes. So now we have, this one just comes down, z plus 5. And z squared minus 4 becomes z plus 2 and z minus 2. And I know that z plus 2 and z minus 2 will not factor for them because z is to the first power. So that was review, factor by grouping. Guess what? There's 2 for you to try. I'll give you 2 minutes to try factor by grouping on either or both of these. Here we go. Issues? Issues? First thing you gotta do is figure out where to put your groups. And then factor each group. And then factor the whole. Oh, that's right. It was X squared. I just didn't copy it. Well, this is not difference of squares because it's just x. This should be x squared. Yes, because you took out the x plus 4 from both. 2x squared minus 1. Okay. You done? No. No. Okay, this one is. This one's not. And you might be hurting yourself because you put in a weird order. Okay, back to the first power. So it might factor further. Alright, number 6. Number 6 should have 3 parentheses when you're done. I'm going to do number 6 up here. First, grouping them. Then I'm taking out my GCF. And then I'm going to factor out my x plus 4 from both terms. When I factor out my x plus 4, I have x squared minus 1 left over. X squared minus 1 is a difference of squares. So x squared minus 1 has to be x plus 1 and x minus 1. Then it's done. The other parenthesis, or the other, not parenthesis, the other question. Group them however you feel like you should get them grouped. There has to be a plus sign in between. Take out GCF y squared, and over here 3. And 3y plus 1 is now the GCF of the whole thing. When I take that out, I have left over y squared plus 3. And then I need to see if they factor further. 3y plus 1 is fine because it's just the first power. 3y to the first power is fine. Y squared plus 3 has a second power. So I look at what I can do for 2 terms. And my choices are difference of squares or the cubes, which we haven't learned yet. Is this difference of squares? What's wrong with it? Why is it not difference of squares? It's addition. And 3 is not a perfect square. So we're done. You can't factor it any further. That's it. All right, we ready? Ready for the new stuff? Ready? Okay. I can see. I can see you're totally ready. I know whoever's watching this video can't see, but you guys are super excited. I know it. All right. We're going to factor 2 cubes. We're going to factor 2 cubes. It's either sum or difference of 2 cubes. Then we just went back a page. We skipped it already. We won't go with that. The example 2 now. I just wanted to review this stuff we already knew, and now go to the next one. Okay. There's a formula that you need to have memorized. This is the formula that needs to be memorized right here. It says a cubed plus b cubed. Not that I'm aware of, but I'm sure that we can find one. We should look. I know. Well, you'd think it helped you. You know, some people on that long division did not sing the whole song, and I wrote on there, like, bring it on down, question mark. Some of you missed part of that song. Most of them? Oh, that one helped you? All right, excellent. I'm glad you remember it because we're going to still be using that. Okay, so this is a formula you memorize. I don't know that song. We'll have to look at see if there is one. This is a formula you memorize. I'm going to use it as we do the examples, so I'm not going to keep staring at this up here. But to help you when we do the examples, let's write down a list of like some perfect cubes that you could refer to if you need it, so you don't have to keep pulling out your calculator if you don't know them. You see where it says list of perfect cubes on the side there? See it says over there? I'm going to list some cubes. So cubes would be something like 1 to the 3rd power. What's 1 times 1 times 1? 1. 2 to the 3rd power. What? 2 times 2 times 2? 8. Oh. 3 to the 3rd power? 27. 4 to the 3rd power? 64. 5 times 5 times 5? 125. 6 times 6 times 6? It's 216. It's 216. What's 10 times 10 times 10? 1,000. All right, now what if I did something like -2 to the 3rd power? What if I did -3 to the 3rd power? So cubes can be negative. Squares cannot be negative, but cubes can be negative. What if I did x times x times x? X cubed is x times x times x. What if I did x squared times x squared times x squared?
6.
What if I did x to the 3rd times x to the 3rd times x to the 3rd? X to the 9th.
9.
Oh, she said 6. Thank you. Okay, sorry. Whatever I do, x to the 4th times x to the 4th times x to the 4th. What can you tell me about the exponents if it's a cube? Okay, not how we get it, but like if you're just looking at the exponents, like the 3, the 6, the 9, they're all divisible by 3. So that's how you know that it is a cube, is because the exponent's divisible by 3. Okay, so there's a list that you might need. Now let's do an example. So to do an example, what I'm going to do is I'm going to write down the formula every time until it is so memorized in my brain I don't have to write it down anymore. I would highly suggest you write down the formula too. Underneath this, I'm going to write down the formula. The formula is a cubed plus b cubed equals, parenthesis, a plus b, close parenthesis, open parenthesis, a squared minus ab plus b squared. That's the formula for factoring cubes. Now underneath that, I'm going to write down what I'm trying to factor. X cubed minus 125. Now my formula is a cubed plus b cubed, and here it's a cubed, or something cubed minus. So I'm going to change it so both of them say plus. Ready? Instead of subtraction, I can make it plus a negative. Right? Those mean the same thing. I'm going to use that formula. The purple formula says a cubed plus b cubed, and then the first parenthesis is a plus b. So you ask yourself, what cubed is x cubed? What's the cube root? What cubed is x cubed? Now, what cubed is x cubed? X plus what cubed is negative 125? What times what times what is negative 125? Negative 5. So what I did was I cube rooted, just like square rooted, only I cube rooted, that is the thing, cube rooted these, so I could find what's the first parenthesis. The second parenthesis, I'm going to use my first parenthesis to get the second parenthesis. I'm going to use first parenthesis. So here it says a plus b. I have x plus negative 5. Here it says a squared. So whatever is a, I'm now going to square it. So whatever's in my a spot, square it. X squared. I like to do the first and last term, just that's just the order I like to go. So whatever's in my b spot, I'm going to square it for b squared. So what's in my b squared, or b spot? Negative 5. What's negative 5 squared? Positive 25. Then in the middle, I do minus, and I have to multiply a times b. I do minus, then I have to multiply a times b. So a and b are these two things right here. What's x times negative 5? Negative 5x. So now I'm just going to clean up what I have, get rid of some of those extra signs in there. What I have factoring is x minus 5, and then x squared plus 5x plus 25. That's using a formula. What's really nice about this formula, if you learn it, is this part right here might factor further, but it's a binomial. How do you factor binomials? Two terms. How do you factor two terms on the front page? There's the squares or cubes that we just learned. But this part right here will never factor further. Even though it's a trinomial, you don't need to do guess and check. It's done. I promise you, every single time when you use this formula, this part is done. Okay? You don't need to factor that any further. So just look at the binomial. Can we factor x minus 5 further? Nope, then we're done. That's the factor. Let's do another example. All this is memorizing a formula. That's all it is, promise. 16 s to the 5 plus 54 s squared. First step of factoring always is our GCF. Yes, there is. What is it? 8 doesn't go into 54. 16 doesn't go into 54. 8 doesn't. S squared is part of it. S squared is part of it. But there is a number that goes into both. 2. I'm sorry, everybody in my first class said 8 also. But 9 goes into 54, not 8. Okay, so I factored out my greatest common factor, 2s squared. I have left over 8s to the 3rd plus 27. And we can look at our binomial and say, what are my ways of factoring a binomial? Is it a difference of squares? Is it subtraction? Well, I know it's not a difference of squares. Is it a sum of cubes? Well, what would be the cube root of 8? 2 is correct. What's the cube root of s cubed? 2s plus, and what's the cube root of 27? 3. I just put that in the wrong spot though. Move it over a little bit. So what I'm doing now is I'm using my formula which says do a plus b and then a squared minus ab plus c squared. That's the formula I just copied down from the core concept. I just literally copied it. Then the first parenthesis is you do the cube roots. You do the cube roots. So I was writing it as we were talking about what the cube roots could be. I was writing them down. So the second parenthesis, once you have the first parenthesis, you can get the second one. So we do a squared. That means whatever this first term is, square it. That's 2s times 2s. 4s squared. The last spot is you square the second number. 3 times 3, 9. The middle spot is you have to multiply a times b and subtract it. So my a and my b are 2s and 3, so that's 6s. And you have to subtract it. That's the formula. I'm going to bring my GCF down and write it in front. 2s squared. And we have 2s plus 3 times 4s squared minus 6s plus 9. I just brought everything down. This one is the only possibility of factoring further is that 2s plus 3. I've already told you the trinomial won't factor further. Can 2s plus 3 factor further? Not factor further. No. S is to the first power won't factor further. You're done. Factor the polynomial completely. The first one, you look at it. What do you ask yourself first? What do you ask yourself? Is there a GCF? Nope. Then we say, you know what? I'm seeing some 3's here. Is this maybe cubed? What's that cube formula? A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. If this is a perfect cube, then what's the cube root of a cubed? What times what is a cubed? A. What times what is 27? 3. So that's my first parenthesis, a plus 3. Second parenthesis, you use the first parenthesis. You take that a and you square it. You put it here, a squared. You take the 3 and you square it and you put it last, plus 9. The middle term, you have to subtract the two numbers multiplied together. So subtract 3a. The first parenthesis, a plus 3, does that factor further? Nope. The second parenthesis, a squared minus 3a plus 9. I don't even need to check it. I've already told you that one won't factor further. So we're done. I'm rewriting number 5 because I don't have enough space over there. Number 5, what should we do first? Is there a greatest common factor? The 6 go into 755 each year? Excellent. Any variables also in common? Z squared? So I have z to the third minus 125 left over. And we say z to the third minus 125. Is that perfect squares or perfect cubes? Cubes. All right, then I need to know my formula. So I'm rewriting it again so that we learn it. But if I rewrite it, that does not help you learn it. You have to rewrite it every time so that you learn it. Okay, so I'm going to do the a plus b part first. A plus b. I need to know what a is. Here's z cubed is a cubed. So what's a? Z cubed is a cubed. These are the same. So what's a? Let's look. Z plus. Here I have a negative 125. So that's the same thing as plus a minus 125. So what is b? What to the third power is negative 125? Negative 5. So my second parenthesis, I'm going to square the a, so I'm going to square z squared. I'm going to square the thing that comes last of 25. And then I have to multiply these together and put them with subtraction. So I'll get negative 5z. We'll simplify it. I'm going to put my GCF in front because we don't want to forget about that. That's part of it. 6z squared times z minus 5 times z squared plus 5z plus 25. Oh, that was fun. These are cubes. All it is memorization and practice. That's what cubes are, memorization and practice. So take that. Try that. And look for a song on the internet. Come prepared with the song tonight. One more example or two. Just go to example 4 to make sure we know how to do these. Not really learning. We've actually done these already. Just reviewing this. Example 4. We're not doing the rest of the packet after example 4. That'll be tomorrow, not today. So example 4, what's our first step of factoring always? Is there a GCF? Okay, no. Then the second thing is how many terms we have. We have 2 terms. So my choices are a difference of squares or a difference or sum of cubes. It's not sum. So our choices are difference of squares or difference of cubes. Or none of the above. Okay, well, 4 is 4 a power of cubes, or 4 is a power of squares. Right? It's like squared, squared. This is a difference of squares. We'll have 2 parentheses, and we'll square root each, and we'll have 4x squared plus 9 and 4x squared minus 9. With the difference of squares, it just has a 4th power to the square, the 4th, which is 4 squared, 4x squared. Then you have to look at each parenthesis. Now I have a binomial, and it is a sum. My only choice for sum with a binomial is sum of cubes. Is this cubes? No. So this I can't do anything with. Over here I have subtraction. I have a binomial. My only choices for subtraction with a binomial would be difference of squares or difference of cubes. This is not a cube, but it is squares. So this one goes further. We're going to bring down that one. 4x squared plus 9. This one becomes 2x plus 3 and 2x minus 3. So it's okay if one of your exponents is not a 2 or a 3. You can still do it. You have to think about if it's going to be a square or a cube. How about this one over here? What's my first step? This is the last one we'll do together. What's my first step? What's the GCF? 3p squared. So I factor out 3p squared, and I get p to the 6th plus 5p to the 3rd plus 6. What do I have there? How many terms? How many terms? 3, so it's a trinomial. How do I factor trinomials according to my first page? On my first page, how do I factor a trinomial? If you don't know the answer, you should be looking. How do we factor a trinomial? Guess and check. This is not for the cube thing. This is not the cube thing. This is guess and check. So this one is 3p squared. Ladies, gentlemen, you know how to do this one already? We're doing guess and check. Did I give you this yet? What times what equals p to the 6th? Too hard? Let's think of the last one. What times what equals 6? 1 times 6, 2 times 3. Which numbers am I going to use to get a 5 in the middle? Okay. And everything's addition, so I know it's going to be plus. Now think about this. When we FOIL it back together to check our answer, our outer and our inner has to add up to be 5p to the 3rd. Right now I have 3 times something and 2 times something. What's that 3 need to be multiplied by? To add up to be 5p to the 3rd. Am I asking a hard question? Yeah, p to the 3rd. So I will get 3p to the 3rd plus 2p to the 3rd is 5p to the 3rd. So when I say what times what makes p to the 6th, you could tell me, well, p to the 3rd times p to the 3rd. And you got to check to see if these go further. So p to the 3rd plus 2. It's addition to the binomial. It's got to be the sum of cubes. Is it a sum of cubes? What times what makes 2? Okay, then it's not a sum of cubes. Is this one a sum of cubes? No. If it was, it's not. Because 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. We're already past 3. So this one does not factor further. If so, you would need to factor it further. This one does not. Your assignment is a worksheet that you are not putting away right now. You have 5 minutes. You will be starting it right now. Yep. Get started. Get started. Welcome back. Get started. Welcome back. Get started. We got 23 days until your next break. Think about it that way. We're running a race. You are running a race. What do you do on the final lap of the race?